Hi, my name is Steve Morgan. I'm the Motion Control Product Manager for Gerrie Electric. Today I want to do a video on Motion Made Easy, how it is to set up a two-axis system using our Kinetics 5500 demo case and our Compact Logix L36 ERM demo case. So the first thing we're going to do is start up a Studio 5000 project. We're going to select New Project. The demo we're going to be working with is a Compact Logix 1769 L36 ERM processor. We'll give our project a name. Select the Next. Our processor is sitting at version 30 of our Studio 5000. Okay, you should have this screen now. So first thing we want to do is we want to go to the properties of the processor. Right click on the 1769 L36 ERM, select properties. You want to go to the date time folder, and we're going to enable the time synchronization. All motion has to be owned to a time master. Hit the apply. OK. Next we're going to go to the Ethernet connection. Right mouse click, add a new module. Our Kinetics 5500 servo drives that we're using are 2198-H003-ERS. Make sure you select the ERS. Create. We're going to give our drive a name, so we'll just call it Drive 1. The IP address on our demo is 192.168.1.24. Okay, we're going to go to the Power tab. This particular drive can operate off of both 200 to 240 volts or 400 to 480 volts. Since our demo is only 115, we're going to select the 200 volt. We're going to change the AC input phasing to single phase, and we're going to change the bus configuration to standalone. Hit the OK button. Let's add a second drive. We'll call this one drive number 2. Its address will be 192.168.1.25. Same thing for the power structure. We'll make it 200 to 240, single phase, and standalone. Okay, so let's close the window here. We're going to go back to our first drive. We're going to go to the associated axis tab. We'll add a new axis. This will be your physical motor that's attached, so we'll just call it MTR1. Create. Let's go over to the digital input tab. You can see you have two digital inputs. These can be configured for unassigned, home, registration 1, registration 2, positive over travel, negative over travel, or home and registration 1. We're just going to leave them unassigned because we won't be using them for this demo. Hit the apply. OK. Do the same thing to drive number 2. Associated axis, new axis. We'll call this one MTR number 2. Create. Same thing for the digital input. Since we're not going to use them, we'll leave them unassigned. Apply. OK. Now you can see the two motors that we created are under the motion group but are ungrouped axes. So let's go right mouse click on the MTR. Number 1, properties. First thing we want to do is create a motion group. You can do this several ways. You can simply mouse click here, new motion group, or when you're building your axis, just go to new group. Keep it simple, so we'll just call it MG for motion group. Create. We can now select this axis to go to that motion group, hit apply, and you can see over here that the MTR1 has been moved up to our MG group that we just created. So let's finish off this configuration here. We'll go to motor. Under the nameplate datasheet, use the pull down arrow to get to the catalog number. Next, click on the change catalog. The motor we are using are a VPL-A0631M-P. This is one of our smallest servos motors, and the P is for absolute feedback. Make sure you select the highlighted part number here, select OK, hit apply. So our motor is now owned to this particular axis. You can go through the motor feedback and see that it is a hyperface DSL. It is absolute high resolution multi-turn feedback. Under the scaling, we're just going to leave the direct couple for rotary. If you are connected to a rotary transmission or linear actuator, you would select these two, and then you would come in and select your actuator type. Since we're just simple couple motors in the case, nothing really attached to it, we're just going to change our units to revs, hit apply, and we'll leave the scaling the way it is. Because this is a 230 volt drive and I'm only operating off 110, I have to go down to the actions. I have to go to the bus under voltage user limit, hit the pull down arrow and select ignore. Otherwise it's going to trip on under voltage. Hit apply. Say OK. Now for motor number 2, we can simply hold your mouse, drag and drop it into your motion group, double click on MTR2, do the same thing, go to your motor, change it to catalog number, change the catalog number, same motor, so VPL-A0613M-P, select the highlighted motor number, OK, hit the apply. Going to do the same thing for scaling. Just going to put it to revs for units. Go to your actions tab again. Go to the bus under voltage user limit. Select the ignore. Apply. And OK. So if we come up to the main program, you can see we have no program running here. We're just going to delete this rung. Okay, so we have no program operating. I have configured a processor, making it the time master, configured 2 axes to the Ethernet connection, given the axes IP addresses, assigned motor part numbers to it, assigned tag names to the 2 motors, calling it MTR1 and MTR2, and assigned the appropriate motors that are being used in the demo. So we can check our work to make sure there's no problems. You can see there's no errors, no warnings. So once again, I have no program running in this yet, but that's okay. We can still command some motion. So we're going to go to communications, Who active. We're connected through the USB port to the processor, and then we're going to download this to the processor. Hit the download. Change it back to run mode. Now we're online. So once again, I have no programming running, but I can actually get some motion going with these 2 axes. So let's go over to the trends. Right mouse click on the trend. Select new trend. We'll give it a name. We'll just call it motor feedback. We're going to change the sampling period to 2 milliseconds, and that is based on our course update time. I'll hit the next. I want to go in to your select tag, find MTR1. This little icon button here will put everything, all the tags in alphabetical order. I want to scroll down until I see actual velocity. we'll pick him, add him to the trend. Motor number 2, expand. And we're going to select the same tag. So actual velocity, add, finish. Now I mentioned earlier about setting your update time to the same values of your course update time. Course update time is set under your motion group. Right mouse click on the MG, go to properties, go to your attribute, and there's where your base update time is set of 2 milliseconds. Hit the cancel. Now, next thing we do, we have our trend running here, but we have to enable those 2 attributes coming back. So, let's go over to the properties of our MTR1. Okay, so in order to bring back real-time tag values from the motor, we have to go to the properties of the motor. So in this case, MTR1. You can right mouse click or double click. You'll have the property windows come up. Go to the drive parameters, select the velocity feedback, because that's what we want to see coming back. Hit apply. Okay. Let's do the same thing for MTR2. Parameters. Velocity feedback. And hit apply. And OK. Let's right click on MTR1. Select the motion direct commands. The MSO turns the servo loops on for motor number 1, so let's go ahead and execute that. We'll do the same thing for motor number 2. Execute. Next we want to go to an MAG, motion axis gear. Motor 2 will be the slave, motor 1 will be the master. We'll leave it at a 1-to-1 ratio, and everything else can stay the same. We'll execute that. Then we want to go ahead and do a motion axis jog, MAJ. We'll put 5 units of speed in there. We'll make sure that it's motor number 1 that's moving, because that's our master. Go ahead and execute. Now we can go to our trend. Let's run the trend. And you can see we have both motors tracking each other, running at about 5 units per second. Hope you enjoyed this video. Stay tuned for the next one. Thank you.